already seen the properties of inverse trigonometric functions. Let us try to justify with the help of trigonometry, which already you know, and some formula of trigonometry. And wherever possible, we'll prove them also. Let's take the first one. Sine of sine inverse x is x. Of course, x lies between -1 to 1, that is domain of sine inverse x. This we can justify with the help of very simple examples. Say for example, sine inverse 1 by root 2. What do you mean by sine inverse 1 by root 2? What is that angle whose sine is 1 by root 2? And of course, in the principal value branch, that is negative pi by 2 to pi by 2. So it is pi by 4. Now here we have sine of sine inverse x. So what is sine of sine inverse 1 by root 2? It is sine of pi by 4. And what is the value of sine pi by 4? 1 by root 2. So what do you observe? That sine of sine inverse 1 by root 2 comes back to 1 by root 2. And that's what is the property. Sine of sine inverse x is x. And it will be true for all values of x as long as it lies in between -1 to 1. And similarly for other functions. Let me take one more example. Tan inverse of root 3. What is the value of tan inverse root 3? 60 degree or pi by 3? Now let's take tan of tan inverse root 3. It will be tan of pi by 3. And what is the value of tan pi by 3 or tan 60 degree? It is root 3. So what do you observe? That tan of tan inverse root 3 gives you back root 3. And so is the property sine of sine inverse, cos of cos inverse, tan of tan inverse x is x. So that's about property 1. We have not proved it very formally, but justified with the help of some good examples. Next. The second property is sine inverse of sine theta is theta, and of course theta lies in the principal value branch. Can you tell me what is the principal value branch of sine inverse x? Yes, it is negative pi by 2 to pi by 2, both inclusive. In the closed interval, negative pi by 2 to pi by 2. How to justify this property? Say sine pi by 3. So what is the value of sine 60 degree? It is root 3 by 2. Now let me write sine inverse of sine pi by 3. So that will be sine inverse of root 3 by 2. What do you mean by sine inverse of root 3 by 2? What is that angle whose sine is root 3 by 2? What is that angle? It is pi by 3 again. So what do you find? That sine inverse of sine pi by 3 is pi by 3. Here I want to emphasize that it is not like a cancellation. Kindly don't think it is cancellation. Of course we may think that it is something like the effect of trigonometry is being cancelled by inverse. We can take it like that somewhere, not exactly pure mathematical. So similarly, let's take one more example. Say cos inverse of cos, say pi by 6. So what is the value of cos 30 degree? Cos pi by 6? Root 3 by 2. And now what do you mean by cos inverse root 3 by 2? What is that angle whose cos is root 3 by 2? And obviously it is pi by 6. So what do you find? That cos inverse of cos pi by 6 is cos pi by 6, and hence the property cos inverse of cos x, cos inverse of cos theta is theta. And similarly, tan inverse of tan theta is theta, and so on. That's about property 2. Now property 3. The first part is sin inverse 1 by x is cosec inverse x. This is applicable in the domain of cosec inverse x. What is the domain of cosec inverse x? It is when x is greater than or equal to 1 or x is less than or equal to negative 1. It is applicable in the domain of cosec inverse x. How to prove it? Take proof. Let cosec inverse x is theta, which implies x is equal to cosec theta. So what is the reciprocal? That is 1 by x. What is the reciprocal of cosec? Sine. So 1 by x is sine theta. Now remember, just see the relation. If x is equal to sine theta, it is a matter of understanding. You take sine on the left. Not, formally speaking, we can't speak like this, but just see the trick. When you take sine on this side, so it becomes sine inverse x equal to 3. When you take inverse on the other side, that becomes sine. Just keep this thing in mind. So, if 1 by x is equal to sine theta, and you want to convert this trigonometric notation to inverse function, what do? Take sine on this side. It is not that sine on this side, I mean take plus, minus or cross multiplication, you know what I mean? It will give you sine inverse of 1 by x equal to theta. And now refer back, theta initially was what? Cosec inverse x. So sine inverse 1 by x equal to theta equal to cosec inverse x. So this proves the relation. Now property 4, sine inverse of negative x is equal to negative sine inverse x. Now please make a note that here in property 4, I have taken the 3, sine inverse minus x, tan inverse minus x and cosec inverse minus x. What is common among these 3 inverse functions? That in all the 3, the principal value branch is negative pi by 2 to pi by 2, of course with exception. By that I mean in case of tan inverse x, this boundary is negative pi by 2 to pi by 2 is not included. Similarly in cos inverse x 0, but more or less it is in the first quadrant and third quadrant. So sine inverse of negative x, it being a negative number, it will lie in the fourth quadrant. Similarly in tan inverse x, negative x, it will lie in the fourth quadrant, and cosec inverse of negative x should also lie in the fourth quadrant. Now how to prove it? Take proof. Let sine inverse of negative x equal to theta. And as I told you earlier, take sine on other side. So negative x equal to sine theta. Shift negative sign on the right, x is equal to negative sine theta. Now sine is negative in the third quadrant and fourth quadrant. But as per principal value branch, we can take it only between negative pi by 2 to pi by 2. So we should adjust this negative sign only like this. That is x is equal to sine of negative theta. Is this clear to you? And now convert it to inverse function. Take sine on the left. So it gives you sine inverse of x is negative theta. And what was theta initially from 1? Replace it. That is negative sine inverse x. So sine inverse of okay, so you find that sine inverse x is negative theta and theta from the back can be replaced by negative sine inverse negative x. Shift theta on the left, and that gives you negative sine inverse x equal to sine inverse of negative x, or sine inverse of negative x is negative sine inverse x. So that is the proof of property 4, first part, and similarly we can prove the other two parts. First part, cos inverse of negative x is pi minus cos inverse x. That's why I have divided, sine, tan and cosec inverse of negative x in one property, and cos, cot and sec in property 5. What is the major difference you find? That in the earlier case it was negative of sine inverse x, and here it is pi minus. Why so? Just look at the principal value branch of cos. The principal value of branch of cos inverse, or for that sake cot inverse or sec inverse, is 0 to pi. When is cos theta negative? In the second quadrant. And in the second quadrant we take the angle like pi minus alpha. Now let's take the proof. Let cos inverse of negative x is theta. So negative x is equal to cos theta, or x is equal to negative cos theta. Now when is cos negative? Cos is negative in second or in third. But we cannot take it in third because the principal value branch is 0 to 2 pi. Either in the first or second. In the first we could take if the value is positive. So value is negative only in the second quadrant. And what kind of angle are there in the second quadrant? Pi minus alpha kind. So it will be cos pi minus theta. X is equal to cos pi minus theta. Converting it to inverse, you get cos inverse x equal to pi minus theta, or take theta on the left, theta equal to pi minus cos inverse x. And what is theta as per our assumption from 1? Cos inverse negative x. So finally you get cos inverse of negative x equal to pi minus cos inverse x. And exactly in the same manner we can prove the second part and the third part, that is cot inverse of negative x is pi minus cot inverse x, and sec inverse of negative x is pi minus sec inverse x. Now next, property 6. It has three parts. The first one is sine inverse x plus cos inverse x equal to pi by 2. Second is tan inverse plus cot inverse x is equal to pi by 2, and third, the rest two, that is sec inverse x plus cosec inverse x equal to pi by 2. Now here x lies in the domain of it, and what is the domain of x? Cos sine inverse x and cos inverse x? It is negative 1 to 1 closed interval. Now let's prove it. Let sine inverse x equal to theta, so x is equal to sine theta. Now do you know we want to involve cos inverse also? How can you convert sine theta into cos theta? What is that formula? You know cos 90 minus theta is sine theta. So let us rewrite it as cos pi by 2 minus theta. And now to convert it in inverse function, take cos on this side to make it cos inverse x is equal to pi by 2 minus theta. And from 1, what is theta? Theta is sine inverse x. So you get cos inverse x is equal to pi by 2 minus sine inverse x. Take sine inverse x on the left and you get sine inverse x plus cos inverse x is equal to pi by 2. So you find it is a simple proof, and it involves trigonometric formula, that is cos 90 minus theta equal to sine theta. Okay, and similarly we can prove the other two parts. Property 7. It has two parts. The first part is tan inverse x plus tan inverse y equal to tan inverse of x plus y over 1 minus xy. With the restriction, it is only applicable when xy is less than 1. It does not mean that if xy is not less than 1, we cannot apply. We can apply, but the property will slightly change. The result will slightly change. Do you observe on the right hand side the expression x plus y over 1 minus xy? Do you see a trigonometric pattern here? Do you know any such trigonometric formula where the pattern is like this, x plus y over 1 minus xy? Yes, it is like 10a plus 10b over 1 minus 10a 10b. This is the formula of 10a plus b. So remember, we'll apply that formula here. You have to recognize the formula pattern. So let tan inverse x is theta, or x is equal to tan theta, and tan inverse y equal to phi, which implies y equal to tan inverse tan phi. So x is equal to tan theta and y equal to tan phi. Now take right hand side of the result to be proved. That is tan inverse of x plus y over 1 minus xy. Substitute the value of x and y. So you get tan inverse of tan theta plus tan phi over 1 minus tan theta tan phi. That's what I was talking of, the trigonometric formula. Which trigonometric formula is this? Tan theta plus tan phi over 1 minus tan theta tan phi. It is tan theta plus tan a plus b type. So you get tan inverse of tan theta plus phi. And just some time before, you have done a property that tan inverse of tan theta is theta only. So using that property, that tan inverse of tan theta is theta, this gives you theta plus phi. And as per our assumption, what was theta? Theta is tan inverse x. And what is phi? It is tan inverse phi. And hence the result, that is tan inverse of x plus tan inverse y equal to tan inverse x plus y over 1 minus xy. Now property 8. The first part is sine inverse 2x over 1 plus x square equal to 2 tan inverse x, and it is applicable when mod x is less than or equal to 1, which is nothing but 1, which is the domain of sine inverse x. Now to prove it, because on the right hand side it involves tan inverse x, so let us take tan inverse x equal to theta, which implies x is equal to tan theta. And now take left hand side, sine inverse of 2x over 1 plus x square equal to sine inverse, replace the value of x by tan theta, you get 2 tan theta over 1 plus tan square theta. Now tell me, what is that trigonometric formula which gives you 2 tan theta over 1 plus tan square theta? Just recollect 2a formula. What is the value of tan 2a? 2 tan a over 1 plus tan square a. So 2 tan theta over 1 plus tan square theta should be replaced by sine 2 theta. What is the formula for sine 2 theta in terms of tan theta? The formula of sine 2 theta in terms of tan theta is 2 tan theta over 1 plus tan square theta. And again, you know that sine inverse of sine theta is theta. So sine inverse of sine 2 theta is 2 theta. And replace 2 theta back by tan inverse x. So finally you get 2 tan inverse x.